Today's lesson, 6.1, exponential growth and decay functions, day 2 is actually going to be much shorter than day 1. So first, we're going to say that earning interest is an exponential growth problem. Right? As you earn money through interest, that becomes part of your balance, which you then earn interest on as well. So if we were to just look at this as a plain exponential growth problem, you put $500 into an account with an annual interest rate of 0.6%. How much do you have in your account after 7 years? So we're going to look at this as the initial amount. We'll say y equals, the initial amount is 500. It's growth, so it's going to be 1 plus 0.6% as a decimal. We know we have to move the decimal place over twice. So that's going to be 0.006. And it's raised to the t power, and in this case, t is 7. So this is what we're evaluating. We're going to do 1 plus 0.006. So we're going to do that first in our calculator. 1.006. That is getting raised to the 7th power. And then that's getting multiplied by the 500. So we get 521.38, right? This is money, so we're going to say 0.38. So $521.38. Right? That's the amount after 7 years. The only problem is we usually do not take interest just once a year. So we have to have something else called compound interest. So compound interest is compounded or added more than once per year. So the exponential growth model that we were looking at, that 1 plus r, must be modified for compound interest problems. So we have a different formula. So for compound interest, P is our initial amount, the amount that was originally deposited. R still represents our annual rate that we turn into a decimal. And now we have a new value, N. We're going to say N is the number of times it's compounded per year. And T still is our normal thing. So our equation turns into A equals P times 1 plus R over N to the N times T power. So we'll just discuss some of the common ways to compound so we get some of these numbers. So daily, if it says it's compounded daily, we have to think of how many days are in a year. And normally, that's 365. All right, we're going to ignore leap years for now. All right, if it says weekly, compounded weekly, we have to think of how many weeks there are in a year. And there are 52 weeks in a year. For monthly, compounded monthly, N would then be 12. Compounded quarterly, so quarterly, think of how many quarters are in a whole, and that's 4. This term is not used as frequently. Semi-annually generally means twice a year. And then yearly, if it's only happening once, how many years in a year? Just 1. All right. Sometimes they do use the phrases bi-weekly, bi-monthly, but those are a little ambiguous because you don't know if it means twice in a week or every other week. So we kind of try to stay away from those. So for our first example, you deposit $9,000 in an account that pays 1.46% annual interest. Find the balance after 3 years when the interest is compounded quarterly. So we know N is going to be 4, and our R turned into the decimal, right? If I move it over twice, is 0.0146. This is the biggest place people make their mistakes when doing these problems. They don't move the decimal place an appropriate number of times, so you have to be really careful with your R's. So that is going to end up being y equals 9,000, and then in parentheses, 1 plus the r value, 0.0146, over the n value. Oops, just wrote that n. Another mistake there. Over n, which is 4, raised to the n times t. T is 3 because it's 3 years, so it's 4 times 3 up here, right? And if you wanted to rewrite that as 12, you could. So now the steps we do this are actually very important. We're going to keep everything in the calculator the entire time. We're not going to switch back and forth between writing it down. I don't need to see every step. So I'm going to go to the calculator now, and I'm going to type this in inside out. So from the inside of the parentheses, we had 1 plus 0.0146 over 4. So I'm going to do the 0.0146 over 4 first, and I'm going to hit enter. I'm going to get an answer for that. So now the parentheses is 1 plus that, so I'm going to add that to 1. Notice how I didn't have to retype it. I just hit plus 1 and it added it together. Now I'm going to raise this to the exponent. We said the exponent was 12, so I'm going to raise. Not going to hit anything, just going to hit raise to the 12th power. So that's the number in my parentheses. So now it's that times the 9,000. And we get 9,402.21, right? Money is 2 places. So my answer would be 9,402.21. All right, let's try another one together. So you deposit $4,000 in an account that pays 2.5% annual interest. So I'm going to write my R right away. 2.5 is 0.025. And then find the balance after 6 years. So that's my T. When the interest is compounded monthly. So N, monthly, number of months in a year, is 12. So we're going to have y equals the initial amount, 4,000, 1 plus 0.025 over 12, all raised to the 12 times 6. So if you wanted to take care of this 12 times 6 right away, we know 12 times 6 is really 72. So I'm going to go back to that calculator, clear out my old stuff. So again, I'm going to do the fraction inside first, 0.025 divided by n, which was 12, add it to 1, raise it to the 72nd power, and now multiply it by my starting amount. And we get $4,646.61. So let's write that out. So real quick, just to jot down everything we just did in the calculator, we started with dividing the fraction. Then we did plus 1. Then we raise it to the nt, whatever that number is. Then we multiply, I'm going to use that asterisk sign, by p. All right, so those are the steps. We divide that first, then we hit plus 1, then we raise it to that nt number, and then we multiply it by the p. All right, so you're going to try the last one. Pause. When you're ready, come back and check your answer. All right, I'll write out both parts. So your equation would have been 8600, 1 plus 0.0132 over 52 raised to the 52 times 4, or 208th power. And then your answer was 9,066.22. All right, that's it for today.